Backpropagation 2. In this module, we will discuss about the general procedure followed by backpropagation algorithms to solve the specific task. Backpropagation algorithms, they are basically a method for training the weights in a multi-layered feed-forward neural networks. As such, they require structure to be defined. A structure to be defined in the net, they require a network structure to be defined, having one or more layers in the network, where one layer will be fully connected to the next layer. So these are the requirements for these bootstrapping algorithms. A standard network structure has one input layer, one hidden layer, and one output layer. So a standard network has usually these 3 layers, but there is also the possibility that the number of layers may be increased. And this is what we say the depth of the network, how much layer a network consists. So, but this is the generalized structure that there will be one input layer, one hidden layer for the processing, and one output layer in the neural network. The method of backpropagation is primarily concerned with adopting the weights to the calculated error in the presence of an input pattern. So what these bootstrapping algorithms do, they are primarily concerned with updating the weights on the basis of the calculated error. So they calculate the error and then they update the weights accordingly in the presence of these input patterns. And the method is then applied backward from the output layer towards the input layer, because it's propagating back the error from the output layer towards the input layer. So that's why the name backpropagation is, and that's why what they are doing, basically propagating back the error. A weight is initialized for each input plus an additional weight for a fixed bias constant input that is almost always set to 0. The activation of a single neuron to a given input pattern is calculated on the basis of the following equation. The activation will be made on the basis of this equation, and this equation is equal to summation of n, where k is equal to 1 into w of k multiplied of x of ki plus w of bias multiplied by 1, where n is the number of this n is equal to the number of weights and inputs. X of ki is the kth attribute on the ith input pattern, and w bias is the bias weight, basically, which is there, a specific entry there in these back propagation algorithms. A logistic transfer function, and usually called the sigmoid function, is used to calculate the output for a neuron. This sigmoid function is used to calculate the output for a neuron in this logistic transfer function. And this logistic transfer function, or the sigmoid function, they basically provide the nonlinearities between the input and the output signals on the basis of this specific equation, where alpha represents the neuron activation. The weight updates uses the delta rule, and more specifically, it uses a modified delta rule where error is backwardly propagated through the network. And when it is propagating the error backward, it is starting at the output layer and weighted back through the previous layers. An error signal is calculated for each node and propagated back to the previous layer, and this is the generalized procedure these back propagation algorithm are using. So by making all these different steps, calculating the error at each step for each neuron, and then propagating that error back to the previous layers, and then to the previous layer, and then to the previous layer, and going towards the input layer. So it's basically calculating the error in a back propagation fashion, and is used generally by different types of neural networks algorithms, especially for the cases of multi-layered feed-forward neural networks.